Right? Now, can you find this P, the probability? The answer is yes. You can find probability, right? You can find a probability. And how? Well, we look at the stock price. We use the stock price information to find the probability. Because we know the price today is 100, the two possible prices will be 250, right? And the probability will be either P or 1 minus P, right? But the thing is, we need the discount rate. We need the discount rate because the stock is the risky investment, right? It's not risk-free. So we cannot use the risk-free rate to discount irreversible. All right? Okay? So we know the price is 200 today. So that's the price today, 200 today. All right? And the expected value, this is 100 today. The expected value will be probability of P, you get 200, and 1 minus P, you get 50. And this is the expected value at the end of the term, right? The period. And we have the discounted back, so we need 1 plus the R, the discount rate. Now this R should be the risk-adjusted discount rate. That means it should reflect the riskiness of this underlying stock. So if there's a stock, it should be RS, right? But in the market, we have thousands of investors. Even in this room, right? We have different types of investors. Some of you more risk averse, some of you less risk averse. Even some of you are risk seeking. You want gamble, right? You want gambling, right? And some of you are risk neutral. That means, yeah, I have millions of dollars. Now, normally, wealthy individual or big financial institution, they are risk neutral because they don't need to worry about losing money, right? Because they're losing their clients' money, first of all, or they are extremely wealthy. So if you look at Elon Musk, losing $1 billion or $1 billion is almost nothing, right? His compensation package is $55 billion, right? So it doesn't matter to him losing $1 million or so. So they are kind of risk neutral, right? Most individuals, they are risk averse. But even risk averse individuals, they have different risk aversion coefficients. Some are more risk averse, some are less risk averse, all right? So assume you pick one of you. I pick one of you. So if let's say your risk discount rate is let's say 5%. Now if you are 5%, then you can determine what the P is, right? If another student, your risk discount rate is let's say 6%. Now I can determine your probability. Okay? But no matter what, today the price is 100 today. So this is your value. Alright? So that means let's just remove the 100. That says, okay, according to your own estimate of P, because different people may have different estimation of P. I believe 200 is high probability and 50 would be low probability. But you may believe 200 is low probability, 50 is high probability. So different of you have different probability estimation, and you also have a different risk aversion coefficient. Alright, so that means everyone should have a different price. Okay, so thousands of you here. But don't forget, eventually this is the market consensus. That is, at this point, everyone agreed 100 is the fair price. So using your P, using a discount rate, you find 100 is good. Because if you think 100 is cheap, then you buy more, the price will be up. If you believe 100 is too high, then you sell, the price will be down. Right? So at that particular minute or second, everyone agree 100 is a fair price. No matter you are risk averse or you are risk seeking, right? Or you are risk neutral. So let's take one of you, which is risk neutral. So let's assume this is an all risk averse individual. So this, let's say right now, there's one individual or a group of individuals that are risk neutral. Now, if you are risk neutral, that means you don't care about risk. Even this is a risky investment, you don't require a risk premium. Therefore, your discount rate is always the risk-free rate, right? Because if I think it's risky, I'm risk averse, I require risk premium, so my return will be the risk-free rate plus my risk premium. But if I'm risk neutral, then I don't care about risk, so I would not require any risk premium. So my discount rate will be just the risk-free rate. Now, if you are risk seeking, you want to gamble, then your risk premium actually is negative. All right, that means your required return actually is less than the risk-free rate because you want to take risk, even though the return is low. But well, just something happened, you become billionaire. You love that. You want to gamble with that. All right. So let's just forget about risk-seeking individuals. Just look at risk-averse and risk-neutral. So for this risk-neutral person, you calculate this price. Okay, let's put 0 instead of just distinguish this from the P, the probability. So your price estimate is this, 200, 1 minus P, 50. And now you discount with your risk-free rate. And now at this particular minute or second, you also agree 100 is the fair price. So using this information, I can find your P. I can find your P. But I don't care the other person. I just find your P. Right? Your estimation of the probability that the stock price will go up. Alright? Okay? Everyone agree I can do that. Right? As long as I can identify one person, he is a wealthy individual or financial institution, and I ask him, hey, why you think $100 is a fair price? Oh, that person, okay, because I believe the probability with this, so therefore I discount it. I calculate expected value, discount risk-free rate, so that's why I believe 100 is a fair price. Right? Okay? Now, therefore, once we have this P, now this person will also use this P to trade the call option. Right? Because the call options depends on the underlying asset. So if they believe the price will have, let's say, 40% chance to go up, that means it will also apply to the call option because the call option is based on the underlying asset. So that individual will also use the same P to determine the call option at that time. So they are using the same P. This is 75. 1 minus P. This is 0. And again, this guy is risk neutral. The discount rate is risk-free rate. All right? So this person say, okay, using my P that I calculate from above, I will use this to determine what's the fair value of this call option. All right? So I will trade. If the price is too high, I will sell. If the price is too low, I will buy more. At this point, everyone agrees this is the fair price. Now, the same thing for risk-neutral individual. They will use their own P. So this P is different. So let's try to, okay. I just call it P prime, right? It's not the same P because everyone will have different estimation of a probability. Right? We do not assume everyone has the same information now. All right? So this time, this person will calculate a call based on the P prime, 200, plus 1 minus P prime, 15. 75 and 0. And then using their discount rate, right? But now at this point, they also agree this is the fair price because everyone using the same P, they use this P to value the stock. They should also use the same P to value the call option. All right? So if we can find this value, then it means this must be the same value for everyone, because this is the market consensus. This is the market agreed price today. So that's why we can use this risk neutral probability. Right? Because theoretically, you should use the risk adjusted discount rate. Right? For normal people, or normal risk averse people. But we have different risk aversion coefficient. Everyone risk aversion will be different. So this approach is, hey, why not we take the risk neutral investor and determine their estimated probability, P, and use that P to find the price of this call option. So we call this a risk neutral probability approach. Alright? So this approach is extremely simple because based on this risk neutral investor, the probability is P, the value is 200. 1 minus probability, the value is 50. And their discount rate, which is the risk-free rate of 8%. So we can find this P is equal to, well, 38.67%. All right? So just please sign the attendance. Okay? So if you calculate your probability is 38.67%, now you apply this probability to your call option payoff, right? Because the call option is when the stock price goes up, your option will have a payoff of 75. When the stock price goes down, your call option will have a payoff of 0. So this is the expected payoff of the call option. And we have to find the present value today. It gives you exactly 26.85. Okay, so any question about the risk neutral probability approach? Actually, it's the simplest approach compared to the replicating portfolio approach. But the replicating portfolio approach actually gives us more information, give us the delta, right? And also, if you later on look at the Black-Scholes formula, it is very, very similar to the replicating portfolio approach. Okay. So now what we can do is, hey, let's try to calculate the call when the strike price is 250. We calculated earlier. So when the strike price is 250, CU is 0, CD is 0. We know that, right? We just calculated earlier. Using this approach, your C also 0, right? No matter what the probability is. Okay. Now next will be when the strike price is 25. You can do the same thing. Well, this time CU is 175, CD we calculated earlier is 25. So now you don't need to redo anything. The beauty of the risk neutral probability approach is you don't need to recalculate delta. You don't need to recalculate B. You just use the same probability because it's the same underlying stock. All right? So now your C is just equal to 0.3867 times 175 minus 1 minus 0.3867 times 7.25. Right? And discount it using 1.08, which is the risk-free rate for that period, and you should get exactly the same 76.85. Okay? Now, how about put option? Well, again, very simple, straightforward. Doesn't matter the call option, put option. The P will be the same. That means we can use the same P to calculate the put premium. But this time we use the PU and PD instead of the CU and CD. Right? So what you need is basically just repeat because it's the same calculation. The P is independent of whether you are evaluating a call option or a put option. Because this P is based on the stock price. Alright? So if you do that, you get exactly 42.59. Right? Now we can do the same calculation for put when the strike price is 250. So remember, when the strike price is 250, PU in this case is 50 and PD is 200. Right? So we don't need to recalculate any probability. Just use the same probability, 0.3867 times 50 plus 1 minus 0.3867 times 200. Discount it using 1.08 risk-free rate. Now you get exactly the same number we get earlier, 131.48. Right? Now finally, if you set this time, you set your strike price 25. Well, PU is 0, PD is 0. Of course, your P is 0. Right? No matter what the probability is, it's always 0. Okay? Now, this is the way I calculate the probability. I use stock price, right? Or using this formula. Now, alternatively, you can use return, right? So I believe in C30 they're using return, so it looks similar but not exactly the same, right? Or some of the end of chapter problem they also use return as well. Okay, so what I do here is I define what is RU and what is RD. That is return when the price is up, the return when the price is down. Right? So basically this is just the return calculation, right? And then what I need to do now is using my risk neutral probability formula in the slide, and I divide everything by S, by the stock price, and then replace SU over S and SD over S by 1 plus RU, 1 plus RD. Right? Just replace this is just 1, so this is become 1. This is SD minus divided by S, so that's 1 plus RD, and this is 1 plus RU, this is 1 plus RD. And then now what I do is just do some simple manipulation, right? Rearrange the formula. Now you should get this equation, right? That is your P is just the risk-free rate minus the return of the stock when it is down over the return of the stock when it is up minus the return of the stock when it is down. Or you can rearrange the calculation. Risk-free rate is equal to the probability of up times the return of up plus the probability of down times the return of down. Right? Or any of this will always give you the same probability. Right? You can do any of this. If the question asks you to use risk neutral probability approach, you can use this one, or this one. Doesn't matter. Okay? Now one more time. If the question asks you to use a particular approach, you have to use that approach. Otherwise, you get 0. Okay? Any questions about risk neutral probability approach? All right. Now I will not talk about that show, but I will talk something about your assignment. Because in assignment, I asked you to do a 2-period model rather than just a simple model. Right? A 2-period model is something look like this. You have stock today, and you have SU, you have SD. Okay. Then you have SUU, you have SUD, and you have SDU, and you have SDD. Right? Okay? So it means the price up in the first period and up again in the second period. The price is up in the first period and down in the second period. Or the price is down and up, or the price is down and down. There are 4 possible outcomes. Right? So if this is a 2-period model, that is, I want you to find the price of an option, either call or put, that's mature at the end of period 2. So what you need to do is similar. You find out this. Right? first step is to determine what your CUU is using the strike price. Using the strike price, you determine what CUU is. Just compare your SUU with the strike price to determine the intrinsic value or the payoff. Right? And then second step is to determine what CUD is using the strike price and also SUD. Alright? And now what you did is, well, using this to determine what CU is. So treat this as just a one period binomial model. You can either use the replicating portfolio approach or the risk neutral probability approach. Alright? Okay. Second step, this time is determine what CDU is, comparing your strike price and SDU. What is CDD is, compare the strike price with SDD, depends on put or call. So I want to generalize, so it can be call or put. Now, and then you calculate this. So what is your CD using another one period model? Alright? So of course you should use the risk-free rate for this period. Right? Now finally, you do this one more time to determine what C is. So this time you do not use your strike price to determine CU. You do not use the strike price to determine CD. Right? You use the CU calculated earlier and the CD calculated earlier in this example. Alright? And this time you have to use the risk-free rate for that period. If the risk rate is the same, then you use the same risk-free rate. But sometimes you have different risk-free rate. Alright? So this time, so basically you use it 3 times to determine what the call option or put option value is at time 0, at this point. Alright? So we can have multiple periods. Let's say this one here. You can see here, if you have 2 periods, you have to do 2 times, right? And if you have 3 periods, you have to do 7 times. If you have 4 periods, you have to do 15 times. Alright? So actually you can do millions of them. So that on this side you also have this is the call option or put option. So you can have this all the way. But always work backward. Always start from the last period, maturity day. Right? You have the same approach. Whenever you work with decision tree, you always work backward. Right? This is the same as you write program to play game. You always work backward. This is the end result. If you win, you give a high score. This is the AI idea. If you win, you give a high score. If you lose, you give a negative score. Right? And then you go back and make a decision. Well, if I face this situation, which path I should choose? Right? I should choose the one with high score to maximize your, working backward. Right? That's actually how AI works. Always look at the result and work backward and find your best decision. So that's the decision tree. All right. So the same thing, you start at the very end. Now, if you divide all this period into very short period, this approach will approach the Black-Scholes formula. All right. That is, you divide, let's say, a 1 month option into millions of small binomial period, binomial model. The result you get will be equal to the Black-Scholes formula. Alright? Now, however, as I said, I would not talk about Black-Scholes first. Let me just move to this one. Alright? That is how we apply the option theory to stock and bond valuation. Okay? Now, I forget whether it's chapter 1 or 2 or 3 or anything. So look at the textbook, look at the return, right? value of a firm. This is the value of a firm. Right? This is the value of a firm. And this is the value of the debt at maturity. That means there's a bond. How much you owe, right? At maturity. Okay? Including interest, everything. Right? So that's the pure discount bond. Right? Now on this one we have the stock. This is the stock value. Equity. Okay? Now what will be the value of the shareholder if the firm value, if the asset value is less than the value of the debt? If you are the shareholder, and let's say you owe someone $10, but the asset value is 5. So how much do you have? Yes, as an equity holder. How much do you have? Anyone? No? Anyone? Let's say right now this is your value of a firm today. If you owe someone $10, the firm owes someone $10, and your firm value, asset value is only $5. So as a shareholder, how much do you have today if you liquidate the firm? 0. Yeah, right. So that means your payoff to the shareholder is 0 when your firm value, asset value is less than the debt value. Now, if your asset value is greater than the firm, the debt, that means you pay off the debt, well, your equity value increased accordingly. So this is the value of the shareholder if today the debt matures. That is, today you have to pay off the debt. Right? So if you compare this payoff, it's very similar to our call option. So the call option here is the underlying asset. So I know it's confusing sometimes. Yeah, why you have 2 S? Well, you can call anything, right? Don't call it S. You can call it A if you want. Right? So this is the underlying asset. You will prove the underlying asset. And this is a strike price. And this is a call option. So the payoff of this, the payoff of this one will be like this. So that means you can see the payoff to the shareholder is exactly the same payoff to the call holder. So that's why we can value the stock using call option. Alright? Okay? Now on the other side, we look at the same thing. This is the value of a firm, and this is the debt value. Now, so this is a payoff to the bondholder, right? To the bondholder. Now, they will get, if the value of the asset is greater than that, they will get what they are owed. Right? So they will get the face value of that. Today is maturity. Right? That means today the debt mature. So now if the company, the asset value is more than the debt, they will pay you the debt. Alright? So you only receive this amount if the value of the asset is higher. Now, if they do not have enough money, they just give you whatever they have. Alright? So if the asset of the value is of the firm is 0, you get nothing. If the asset value is $1, you get $1. If the asset value is $2, you get $2. Alright? So if you look at this one, this is similar to what? This is the underlying asset, right? Let's use underlying asset. And this is a strike price. Okay? And this is like the payoff of this portion. I hope you still remember what this diagram look like. Long call, long put, short put. This one is short put. Alright? So that means a bond is like you short put, but if you short put, you should be this. Right? Your payoff. If you short put, this should be like this. But now you move up. How do you move up? You have a bond. Right? You have a government bond. Right? I told you, well, long call, short call, long put, short put, long stop, short stop, long bond, short bond. So this is long bond. That means you buy the government risk-free bond. But at the same time, you sell put option on the underlying asset. All right? So if you look at this one, a risky bond is the same as you own a risk-free bond or risk-free debt, or which is risk-free bond, but you short a put. So this is a position if you look at a bondholder. Right? Now if you look at a shareholder, you just have a call. You don't own the company. I just have a call. Alright? Just like your mortgage, you don't own the house. Or you lease your car, you don't own the car. Right? Every month you make your mortgage payment. This is a series of call options. If you make your mortgage payment, you have the right to leave it in the house. Alright? And after 30 years, you pay off your mortgage. Now you own the house. So you have the option to own the house. But this is the US, because US you can just walk away. That's the option. But in Canada, no. Right? If you have a mortgage and you do not pay it, they will go after your personal belongings. Alright? So that means in Canada, you cannot default on a mortgage unless you declare bankruptcy. Okay? But in the US, yes, you can just walk away. So in the US case, a mortgage is very similar to call option. Okay? So if you look at it, it says it's stockholders, shareholders, they have a call option. Right? So now is, if you want, you pay off the debt, now you own the firm. If you do not pay off the debt, you just give the firm to the other party. Alright? So that means if at maturity of the debt, the asset of the firm is greater than the value of the debt, then you have the in the money call. So if in the money call you exercise it, you own the firm, you pay off the debt. Right? But normally in real life, company they pay off the debt by issuing another debt. So that means they keep buying call option. Right? Okay? Right? So at maturity of the debt, the shareholder, if the value is left, they have an out of money call option. They just let the call option expire. That means they declare bankruptcy. Right? Now this is from a shareholder's point of view from a put option. Remember, we have put call parity. So we have call is equal to the stock price or underlying asset. Let's say using underlying asset. Alright? And then minus a put option. So according to the put option, sorry. Okay. And this time minus the present value of the exercise price. Alright? Because according to put call parity, it should be call option plus the present value of the strike price equal to the underlying asset plus the put option. So if you rearrange the equation, you can write it this way. So this means this is stock. The stock is equal to value of the firm. Normally we know this is minus B, right? Value of the firm minus the asset minus the debt equal to equity value. Now, if this is negative, of course, you have to write if negative equal to 0. Right? So that means if, because of limited liability, if V minus B is negative, then S is 0. Alright? So now, this is referred to the stock, that's call option, but this call option is also equal to this side. That is, you can look at a shareholder's perspective. This time is the shareholder, they own the firm. But they owe someone a risky debt. Now this is a risky debt. Now this risky debt is equal to If you write it this way, this is equal to, or let's put it like this. That's the present value of the risk-free debt. Now this is, so this is risk-free. I put, use a different color. This is the risk-free debt. This is the risk-free debt. Because in option theory, we are using risk-free debt always. Alright? So that means if you own a bond, if you own a risky bond, it's the same as you own a risk-free bond. But you give a put option to another person. Alright? So in this case, if you look at it, shareholder means they own the company. They own the company. But they have an option to put the firm to the creditor, to the bank. So if the value of this firm is lower than they owe the bank, they just put the company to the bank and say, okay, I give it to you. I walk away. I don't pay my debt. I just give the company to you. So that is, I owe you a debt. I owe you a risky debt I have to pay. If I do not pay, you kill me. But I have the option this time. I sell the company to you at this price. So just cancel my debt. Alright? So this is how we apply the option theory to the capital structure. And also you can use it to find the value of the bond, and also you can determine the bond premium. So actually there's a lot of application. But in this course, we will not go into that detail, but just look at how we apply to it. So everything is based on the put call parity. Everything is based on this put call parity. Alright, so that's what I have. The value of this is a call, this is the underlying asset, this is a put option, and this is the present value of the strike price. Alright? So a shareholder perspective this time is they either own a call, or you can think of they own the firm, they have they owe someone a risk-free debt, but the shareholder they have an option to put the firm to the creditors. Alright? So again, depends on the question. If I ask you to find the equity value using call option, then you have to use this one. If I ask you to find the value of the equity using put option, then you have to use this one. That is, you have to find the value of put option, you have to determine what's the value of a risk-free debt, and what is the firm value, and do this calculation. Alright? Now the other one, this one is from the stock and the bond perspective this time. So this one, as I said, well, as a bondholder, right? So we look at this one here. Okay, right here. Right here. Okay. If you are a bondholder, it's the same as you own risk-free debt. Right? You own a risk-free debt, but at the same time, you sell a put option to the shareholder. So that's why the risky debt, they have a higher price than the risk-free debt, because you also receive the put option premium. Right? So that's why your return is higher, because you get something from this put option. You allow the other party to default. So therefore, you have a higher return than the risk-free debt. All right? And according to the put call parity, the bond value, risky bond value, is also equal to you own the firm. As a bondholder, I own the firm, but I give the shareholder a call option. So you sell this call option to the shareholder. If they want, they can call the firm by paying you off the debt. Alright? So the same thing, if I ask you to determine the price of the company's debt using call option, then you have to use it. That is, you find the call option value and subtract it from the firm value. If I ask you to find the value of the risky debt, the company's debt, and using put option, that means you have to use the value of put option and subtract it from the value of the risk-free debt. Okay? So using this and the previous 2-period model, you should be able to finish assignment 2, question number 4. Actually, I received one student submitting question number 4 already. Okay. All right? So any questions about this? No? Right, so now you can see from here. Remember we talked about the selfish strategy. Where's the attendance? Show the attendance, please. So everybody sign? Okay. Thank you. So remember, when we talk about the agency closed debt, bankruptcy, when a company closed bankruptcy. Now, actually, this is consistent with our option theory. Remember, they want to take high-risk project. Why they want to take high-risk project? Because they want volatility. Right? As a shareholder, if you own the call, right? Remember the relation. Call and volatility, they have a positive relation. High volatility, higher call premium. High volatility, higher put premium. So no matter you look at the shareholder from the call or put perspective, they all want higher volatility. Because high volatility gives them a higher value of the default option. Alright? Because of their limited liability. So therefore, they want higher volatility. Okay? Alright. Maybe what I do 5 minutes. Yeah, maybe I just leave it next week. Okay, 5 minutes I'll bring a finish black show tomorrow. So I will leave it next week to talk about black show, and then we will look at warrant and conversion.